Electronics power the world around us, from signals to alarms to digital displays, simple component build complex machines. Today, we dive into the fundamentals, the LEDs, buzzers, and the 7-segment displays. The first activity of Lesson 1, which is about LEDs, it is called blinking LED. By switching the voltage on and off, we create a simple but fundamental form of digital signaling. The second one is called fading LEDs. We use pulse width modulation or PWM to gradually increase and decrease brightness. This technique is used in dimming lights everywhere. The third activity is called alternating blinking LEDs. By alternating two LEDs, we simulate patterns seen in warning signals, indicators, and embedded systems. The fourth activity is called button-controlled LED. By pushing a button, it triggers the LED to turn on, demonstrating user interaction with circuits. The last activity for Lesson 1 is called LED controlled by a potentiometer. Finally, we vary the brightness using a potentiometer, a variable resistor. Turning the knob changes the voltage, and the LED responds in real time. For the first activity of our second lesson, it is called buzzer on a button press. Buzzer converts electrical signals into sound. Pressing the button completes the circuit and produces an audible sound. The next one is called melody player. By changing frequency and timing, we generate musical notes. This forms the basis of simple electronic instruments. The third activity is called an SOS Morse code. Here, the timing becomes communication. Using patterns of short and long beeps, we send an SOS signal, a universal distress signal. This one is called a light-sensitive alarm. A photoresistor detects light levels. When darkness is sensed, like our hand covering the photoresistor, the buzzer alerts, similar to security systems. For the last activity of our second lesson, it is called a buzzer controlled by a potentiometer. Again, a potentiometer allows us to control frequency. Turning the knob changes pitch, demonstrating an analog control in sound design. The third lesson is about 7-segment displays. The first activity is called displaying a single digit or digit number 3. The 7-segment displays convert digital signals into visible numbers by activating segments individually. The second activity or the last activity for lesson 3 is called counting from 0 to 9 using a 7-segment display. By sequencing these digital signals, we display digits in order. This concept powers calculators, timers, and digital clocks.
Now, let's rewind a bit to the very first activity that we have done on Lesson 1. Since this is our first ever exposure to Arduino Uno, we didn't really know what to do. I mean, we gotta connect each individual wires into the correct segment and then input the right code for it to function. As beginners, we struggle to adapt in this environment. But as we go on and learn more about Arduino Uno, we encountered more problems.
The problems that we face doing the activities about the Arduino Uno are mainly the faulty wiring, the loose wirings, and the troubleshooting. We are very confused when Arduino wiring is correct but it doesn't work because of the faulty wirings, but we managed to overcome it by troubleshooting it.
In conclusion, doing all the activities about Arduino Uno made us more invested in robotics. It honed and sharpened our skills in critical thinking, like solving complex problems, troubleshooting, and wiring basic circuits. Through hands-on experience, we learned how hardware and software work together to create functional systems. Overall, the lessons gave us a deeper appreciation for innovation and inspired us to explore more about electronics and programming in the future.